when we are adding and subtracting fractions with different denominators, we can't always make pizzas and draw bar models and things like that I'm sure you've done in class. Sometimes we just don't have enough time, or we just have fractions that are too big to deal with that, right? To have that many pieces of pizza just gets kind of unreasonable. So what we want to do in order to get the same denominator, right? Basically, we want to begin thinking about equivalent fractions. Equivalent fractions. Okay? So equivalent fractions are simply fractions that are equal to each other but look different. Equal to each other but look different. In the previous part of this video, we talked about how 1/2 was equal to 2/4, right? Because it's the same amount of pizza, right? 1/2 of a pizza is the same if we just cut this into 4 slices. So it goes 1 out of 2, now it's 2 out of 4. All right? So that is equivalent fractions. Now, how do we get equivalent fractions? Again, if we don't want to just continue drawing pizzas. So what we can do is let's take, again, 1/2. And let's think about what we do when we go from 1/2 to 2/4. How are we getting from here to here? Well, what we're actually doing is we're just taking 1/2 and we're multiplying it by 2/2. Okay? Now, the reason we're allowed to do this is because 2/2 is simply equal to 1 whole. Okay? Because you have 2 out of 2. You've eaten 2 slices of pizza out of 2 pieces. So that's 1 whole pizza. Okay? So anytime we multiply a number by 1, it simply equals itself. So we're allowed to do this. Okay? So the golden rule here, okay, is whatever you do to the top of a fraction, you have to do to the bottom. Whatever you do to the bottom of a fraction, you also have to do to the top. If you follow this rule, okay, then you can kind of go on forever. All right, so let's try that. Let's try if we just go, all right, multiply by 2 again, multiply by 2 again, and that gives us now 4 out of 8. 4 out of 8. Okay, and you can keep doing this on and on and on. Okay, so as long as you multiply the top and the bottom by the same thing, it can just go on forever. Now you can also think about this as sort of skip counting, which I'm sure you have done in class, and we can just skip count for both of these numbers. So let's try that actually, because sometimes it can help us understand it a little bit more clearly. So if we skip count, right, 1, 2, 3, 4, 5, 6, right? We're just counting. And then on the bottom, we're counting by 2s. 2, 4, 6, 8, 10, 12. And again, this goes on forever. So there are actually an infinite number of ways that we can write 1/2. Starting with 1/2, then we can just keep going on and on and on. Okay? So I want you to try that actually on your own, except starting with 3 as your denominator. Okay, so if we started with 1/3, okay, and we did some skip counting, what would that give us? So try, go for, let's say 5. So try that on your own. Okay, hopefully you tried it on your own, and what you'll see is we're counting by 3s on the bottom and 1s on the top again. So we have 1, 2, 3, 4, 5 along the top, and then on the bottom we have 3, 6, 9, 12, 15, so on and so forth. All of these are equal. Again, it goes on to infinity. And again, we're just counting by 3s on the bottom. Okay? So this is another way we can think about equivalent fractions. And on the top, we're counting by 1s. All right, so on and so forth, okay? Now, don't be confused by this, right? Because I know I said whatever you do to the top, you do to the bottom. This is only for multiplication and division that rule applies, because really you are doing that, right? You're multiplying. We could think about it as adding 1, right? But we can also think about it as multiplying by 2. Multiplying by 2, right? So 1 times 2 is 2. 3 times 2 is 6. So when you The whatever you do to the top, you do to the bottom rule is when you multiply or divide. So make sure you keep that in mind. Okay, so let's try to do some equivalent fractions, not by skip counting this time, but instead by doing our rule, whatever you do to the top, you do to the bottom. So say we have 2 out of 7, okay? And we want to get a fraction that's equivalent, but we have kind of a mystery number here on the bottom, right? So we don't know our denominator, okay? And then on the top, we have 6, okay? So see if you can figure this out. Okay, so how do we get from 2 to 6? What do we need to multiply by? Well, we need to multiply 2 by 3 to get 6. All right, and whatever we do to the top of a fraction, we do to the bottom. So we also multiply the bottom by 3. 7 times 3 is 21. Okay, so that means 2 out of 7 is the same as 6 out of 21. All right, let's try one more. So say we have 5 out of 15 is equal to a mystery number up top, okay, out of let's say out of 3. Okay, give it a try. Okay, what you should notice is that this is a little bit different, right? Because we're used to multiplying to get it, right? And what you should see is that to get from 15 to 3, we are actually getting smaller, okay? So we can also use division here. So what do we need to divide 15 by to get 3? Well, we need to divide 15 divided by 5. You can also think 3 times 5 equals 15, right? So if we divide by 5, we also need to divide the top by 5. 5 divided by 5, any number divided by itself, right, gives you 1. So 5 out of 15 is equal to 1/3. Okay, and that would actually be how we reduce this fraction as well. All right, let's do another one. So let's do something out of something. Go over here so we have a little more room. Something out of 3, we don't know. Mystery number is, actually let's do something bigger. Let's step it up a little bit. Let's do something out of 18 is equal to 1 out of 9. 1 out of 9. Give it a try. Okay, what you should see is that we need to get from 18 to 9, we need to divide by 2. Okay, or you can think about it the other way and think, okay, we need to multiply 9 by 2, right? So 1 times 2 is simply 2. So 1/9 is the same as 2 out of 18. All right, let's do one more equivalent fraction problem here. Let's do 9 out of a mystery number is equal to 27 out of 45. We'll get a bit higher here with them. Give that a try. All right, to get from 27 to 9, what do we need to do there? Well, we need to divide by 3 because 9 times 3 gives you 27. So 45 divided by 3 is going to give us 15. So 27 out of 45 is the same as 9 out of 15, and you could actually keep reducing that. Okay, so let's try to use our skills with equivalent fractions to help us begin to add and subtract fractions that have different denominators, Okay, so say we have 1/4 plus 5/8. All right, so as we see, these do not have the same denominator. All right, so 1/4 plus 5/8. We need to get the same denominator. How do we do that? Well, a lot of times with these fractions, and this isn't always going to be the case, as we'll go over later, is when we have something like 4, which clearly goes into 8, right? then what we can do is come down here and say, okay, 1/4 is equal to what? Our mystery number out of 8, right? So we just have an equivalent fraction problem. Well, we need to multiply by 2, and that's going to give us 2 out of 8. 2 out of 8. So we need to replace 1/4 with 2 out of 8. So let's go ahead and do that. So we have our new problem, which is going to be 2 out of 8, 2/8 plus 5/8 is equal to 7/8. 7/8. All right, and that's our answer. So we changed 1/4 into 2/8, and that allowed us to then add our fractions. All right, let's try another one there. So let's try 5/6 minus 2/3. We'll do some subtraction. So 5/6 minus 2/3. All right, give this a try. All right, so what you should see is that 5/6, 2/3 do not have the same denominator. So we need to make 2/3 equal to a mystery number up top and a 6 on the bottom. So how do we get from there to there? Well, we need to multiply 3 times 2 and 2 times 2. So 2 times 2 is 4. So that means 4/6 is the same as 2/3, so we can replace that. All right, so our new problem will be 5/6 minus 4/6. Okay, again, we just took 2/3 and replaced it with 4 out of 6. And that gives us 1/6. And 1/6 would actually be our final answer. Okay, so using equivalent fractions, we can add and subtract fractions with different denominators. Okay, let's do 2 more on your own, and then we will move on to reducing fractions. So if we have 3/10 plus 2/5, right, give that a try. So what we're going to do is we're going to take 2/5 and we want to make it something out of 10. So we need to multiply the bottom by 2 to get there. So we also need to multiply the top. Remember, whatever you do to the bottom, you have to do to the top. Whatever you do to the top, you have to do to the bottom. So we get 4 out of 10. Our new problem, therefore, is 3 out of 10, 3/10 plus 4/10. Okay, is equal to 7/10. That's our answer, 7/10. Okay, we took 2/5 and replaced it with 4/10. All right, and one more. Let's do a subtraction. So 7/9 minus, let's do 7/9 minus 1/3. Give that a try. Okay, so we need to get 1/3 to have a denominator of 9. So how do we get 3 to become 9? Well, we need to multiply 3 by 3. So whatever we do to the bottom of the fraction, we also have to do to the top of the fraction. So 1/3, 1 times 3 will become 3 out of 9. So our new problem is going to be 7/9 minus 3/9. Okay, 1/3 becomes 3/9. And that equals 4/9. So again, we just subtract 7 minus 3 equals 4. And then your denominator stays the same. Okay, so the big concept to keep in mind here, because this can be abstract sometimes, is that when we replace and transform 2/5 into 4/10, right? This is the same value, okay? And 1/3, 3/9. These are the same value. It's just a different way of representing the same amount, okay? Again, pizza is always the best way to think about this, right? If you have a big pizza and you cut it into 5 slices and you have 2, that's the same amount as if you cut it into 10 slices, because the slices get smaller and smaller as you cut them, right? And then that becomes 4 instead, all right? So if we visualize that real quick, right? We have 3 slices. Then if we want to make it 9, right, we need to cut each of these into 3 slices. Okay, now it's not perfect, but you see how the slices keep getting smaller and smaller the more we cut them up. All right, now real quick, let's use our knowledge of equivalent fractions to reduce fractions, okay? So say we have something like 20 out of 25, okay? And this is what's called not simplified, okay? And what we want to think about is, do these numbers have any factors that in common? So is there a number that goes into 25 that also goes into 20, okay? And what we should say is, yes, we do, okay? We have 5. So we can divide both of these by 5 and end up with whole numbers, okay? So 20 divided by 5, whatever you do at the top, okay? 20 divided by 5 is 4. 25 divided by 5 is 5. And this is okay because whatever you do to the top, you do to the bottom, so we're good to go. So 20 out of 25 is 4/5. All right, so let's try one of those on your own. So 12 out of 28. What's that going to equal? All right, so let's try this. So what you should see is you might have thought, well, I know these are both even, so why don't we divide it by 2? All right, well, what happens if we divide it by 2? We get 6 out of 14, okay? That's totally cool. These are still the same, right? But what you should notice is that this is actually not fully reduced yet, because 6 out of 14, again, 2 goes into that again. So we can continue going. And then we get 6 divided by 2 is 3. 14 divided by 2 is 7. And now we say, oh, that's sort of the end, right? We can't keep dividing by anything to get us smaller and smaller. So our answer is 3 out of 7. And this is an okay way, it's just not as fast, but it is fine to reduce in this way. Just keep dividing by a number that you know until you get to the answer. Now, you could have done this faster, right? By doing 12 over 28 and then going ahead and dividing by 4 at the very beginning, okay? And then that would give us 3 out of 7, okay? And the reason that is because 4 is what's called the greatest common factor, okay? And but you don't actually have to do that, right? As I said, you can just do it in steps. But if you go ahead and divide by the greatest common factor, it saves you time. Okay, let's try another one on your own. So if we have 25 out of 35, okay? Try to find the biggest number that goes in before you divide. Okay, so hopefully you saw these both end in 5, so 5 is a pretty big number, so maybe 5 is the greatest common factor. And in fact, you are correct. 25 divided by 5 gives us 5. 35 divided by 5 gives us 7. So 5 out of 7 can't go any further, so we are simplifying, okay? So this is how we use equivalent fractions and our rule, whatever you do to the top, you do to the bottom, in order to simplify or reduce fractions.